Hello, and welcome to the BMC Quick Course series. My name is Ken Zolkowski, and I'm a lead product developer based in San Jose, California. In this session, we will look at what is new and improved in Total Object Manager version 8.3. Let's start by looking at the new features introduced in version 8.3 for Tom. There are some parent objects that issue the start and stop commands for their children as necessary. DB2 is an example of this sort of object. By default, DB2 starts the children needed and maintains their availability. Users want to be able to monitor the parent and the children via TOM using a view like TOBJ. This allows them to immediately know the status of the parent and its children. Prior to version 8.3, this monitoring required customer-written automation. Version 8.3 provides a new action that relieves the need for custom automation. Users can now define a dependency on a parent object and identify if the parent will issue the start, stop, or restart commands for the child. Tom will keep track of the child's status and report it in all the ways that it presently does. Tom will not, however, act on the behalf of the child in accordance with the instructions you set in the dependency entry, all without extra rules and/or execs. This version of Tom introduces a new extension. It's called the Generic or Stateless Management Extension, GSM for short. GSM is used to define a system resource that is not managed by one of the existing extensions, STM, UPM, or WRM. A system interface command is an example of a GSM resource that has no status. Printers, VTAM nodes, or job initiators are examples of GSM resources with a status. GSM objects could be dependents of objects such as VTAM or JES. When a shutsys is requested, Tom stops the resources depending upon VTAM or JES like nodes and printers in dependency order without the need for an exec. Tom brings down the parents of the GSM objects when it knows that the children have been properly terminated. Define a GSM object as you would any other. It can be normal or transient. Its availability can depend upon other objects or schedules. Determining the presence of the object in the system is done by specifying either start, stop, or append events, or an active check program. In Tom, making a lock request against an object indicates that you want an object to come down and remain down until the next IPL occurs. There are times, however, when you don't need the object locked now, but at the next IPL. This means that custom automation must be written. With version 8.3, custom automation is no longer needed to lock the object at the IPL. A request via the UI, API, or a console command can mark an object as lock at IPL. No actual changes take place until the IPL occurs. Options indicate if the locking is supposed to take place for every following IPL or just for several IPLs. If an object is already being locked at IPL, the No option disables locking in the local system at the next IPL. The request to lock at IPL can be for a single system or all the systems in the object's VSL. Knowing when an IPL is complete allows users to not only know when the system is ready for processing, it also allows for needed automation to be scheduled. It frees operators from having to manually make this check, allowing them to work on more important tasks. An enhancement to Tom relieves the need to ensure that objects are in an active status after an IPL. New messages, as you see on this slide, indicate how many objects need to be started at IPL, as well as when all of those objects are in an active or complete status. Considerations have been made for objects that are blocked, designated as locked at IPL, or marked as suspended when determining if the IPL is complete. There are times when object definitions are made to an active definition base when the object has already been started in the system. If this is a transient object, Tom will not know that the object had already run. It will try to run the transient again. Depending upon the transient, this could cause trouble in the system, trouble that could have been avoided. This enhancement will allow users to set an initial status when an object is being added or edited. Status can be set as locked, blocked, or complete. Objects that are models or layer objects cannot take advantage of this facility. You also cannot change the status of an existing VSL entry for an object in an active definition base. Setting the initial status of one or more objects is also possible from repeating or activating a definition base. The initial status of an object can be set to locked or stopped by a repeat or activate request. If the object is a transient, then the status can be set to complete. Users also have the choice to set the suspend control so that TOM will either manage or not manage objects when the definition base is activated. All this will help avoid any negative impact to the enterprise when new definitions are added or definition bases are activated in a fully running system. An enhancement has been made that enables TOM to write a message to the log whenever a command is issued. This can be helpful in diagnosing problems with customer-written automation. This slide shows examples of the new messages. New message MAMIC1227I is issued whenever a pre-start, pre-stop, or recovery command is issued. New message MAMIC1226I is issued whenever a start or stop command is issued. New message MAMIC1228I is issued whenever a post-start or post-stop command is issued. Every message contains the object's name as well as the command's tag, number, and label. The post-start and post-stop messages also contain the command delay time and iteration number. In addition to new features in version 8.3, improvements were made in several areas. Prior to version 8.3, registry dump datasets had to be predefined. We also did not provide an offload process. This meant as soon as another registry dump took place, the previous offload was lost. This prevented users from having historical backups of their registry data. New changes to the registry task provide the ability to dynamically allocate datasets to create incremental registry backups. The registry dump dataset name parameter can also accept system symbols as well as time and date symbols. This allows TOM to create unique dataset names for each registry backup. Dynamic allocation coupled with the creation of unique dataset names results in the prevention of overwriting a previously dumped registry dataset. An object status is a very important piece of information. It shows the current condition of the object in the enterprise. It can cause needed actions to take place, either by the machine or by humans, to ensure the defined availability of the object. Sometimes the reason for an object status can be unclear. Why is the object stopped versus locked or blocked? As we can see on this slide, there are several factors to consider when determining the status of an object. Users need to know the values associated with these factors and the impact they can have when setting the status. Improvements made to version 8.3 will cause new status analysis logic to operate when a hyperlink is selected under one of the columns you see listed on the bottom portion of this slide. When selected, analysis occurs taking the factors into consideration and quickly reports its findings to the user. Here's an example of the messages provided by TOM to the UI for an object with the status of stopped. As you can see, we report the status of the object on two systems. We also show the desired and detected state for the object in the local system. Finally, we provide the reason why the status of the object is stopped. As you can see, the dependency that this object has on another object is not satisfied. This leads to the dependency formula specified in the definition of this object having a result of false. The user now has a clear explanation of why the status of this object is stopped. A dependency on another object is not being met. Status analysis can also be provided for a single object via the Object Show console command. Unlike triggering analysis in the UI, messages resulting from the Object Show command are written to Tom's job log. Lastly, users must remember that status analysis can only be performed for objects in the active definition base. During version 8.2, an enhancement was made to the TOMEXEC list and TOMEXEC GET commands. It was done to improve the performance of the MAM export and MAM stat utilities. Generally, when users want to process many objects in an object definition base, they will issue TOMEXEC list. This is followed by TOMEXEC GET for each object to be processed. Each TOMEXEC GET command utilizes resources to obtain the information on the object named in the command. This enhancement changes TOMEXEC list to create a copy of registry data and a token pointing to that data. The token and registry data copy can be used by TOMEXEC GET instead of accessing the registry, thus saving system resources. When finished with the copy of registry data pointed to by the token, issue the TOMEXEC list again to delete the copy and the token. The enhancement has been externalized in version 8.3 along with updates to the documentation and examples in the wiki. We found that too many status variable update requests were causing Tom to run out of memory at IPL, shut down, and other periods when a high number of status update requests took place. Changes were made to improve performance by implementing a new automation variable task. This task, when detecting high update activity, will reject individual requests in lieu of a single request that will update the status variables for all the objects. Thank you for your time. For more information on any BMC mainframe product, please visit the URL shown here.